Hello students, welcome to the class. So today we'll be doing the theory part 2 of the chapter Organic Chemistry, some basic principle and techniques. In this theory part, we will be mainly focusing on the in-text questions. So we have already discussed about this hybridization of the carbon in different cases, and we have seen the impact of hybridization on different bond parameters and the electronegativity. So we will exploit that same result in this lecture to solve questions. This is the disclaimer. Now, if I talk about the questions that I'm going to cover, so there will be some practice questions from my side. In addition to that, you will be seeing the in-text question of the NCERT, which is 8.1, 8.2, and 8.3. So let us start with the first question, which is a practice problem. Here you are given 4 options, right? And out of these 4 options, you have to decide that the marked carbon with the star sign is out of which it is having the highest electronegativity. Okay. So you should remember one more thing, which is the electronegativity is totally dependent upon the hybridization. In this case, because we don't have any other heteroatom, we have carbon and hydrogen only. Your time to solve this question starts now. Just try to determine the hybridization for each of this and see that which one is having the greatest S character. So this would be a hint to you. So you have 20 more seconds to go. The first question that you should ask to yourself is your relation between the hybridization and electronegativity. So I will focus on that thing. So electronegativity of a carbon atom depends upon the state of hybridization, and it is the only determining factor until and unless there is a heteroatom presence. Now how do we relate this? So we relate this with the help of S character. So if your hybridization has greater S character, then it has higher electronegativity. How is this result coming from? You must have seen in the previous class that we said that orbital penetration is greater for the s orbital, and since it is greater for the s orbital, then the orbital having greater percentage s character will have greater penetration towards the nucleus. So it will spend more time near the nucleus. As a result, it will have a greater electronegativity. Now the question is that which hybridization has a greater percentage s character? So to discuss that, we have a table. We have seen this calculation already in the previous class. There I have mentioned about this percentage S character. So if your carbon is sp3 hybridized, it will have 25% S character. If it is sp2 hybridized, it will have approximately 33% S character. And lastly, if it is sp hybridized, then it will have 50% S character. Now you can clearly see that the percentage S character is highest for sp, then it is lower for sp2 and lowest for the sp3. So we can also say the electronegativity will be highest for sp, lower for sp2 and lowest for sp3. On this basis, we can easily say that out of the 4 options, the third option is having the highest electronegative marked carbon. How? Let us see. So if you look at the compound in the option number C, you would notice that it has 2 sigma bonds. How? So the marked carbon in the third option, on the C option, has 2 types of group. One is the carbon on the left side and one is the hydrogen on the right side. From the right side hydrogen, it is making 1 sigma bond, and from the left side carbon, it is making 3 bonds, out of which 1 will be sigma and 2 will be pi. So that will count up to a total of 2 sigma bond, one coming from carbon-carbon and one coming from carbon-hydrogen. Therefore, its hybridization will be sp. You know it very well. just from the previous slide that sp has the highest s character and the highest electronegativity. So the option C will be the correct option for your given question because sp carbon has the highest electronegativity. If I ask you what will be the hybridization for the carbon marked in option A, option B, and option C, then in the option A, 4 sigma bonds are present with the third carbon which is marked. From the left side, if you count, it is the third carbon. And this carbon is having 4 sigma bond, 2 with the hydrogen and 2 with the carbon present on the either side. So that will result in a sp3 hybridization. Whereas in option number B and option number D, the carbons which are marked are having 3 sigma bond that will result in a sp2 hybridization. So we will say that in this case, the option C is having the sp hybridization and hence the marked carbon is having the highest electronegativity. I hope this is clear to you. Moving on to the next question. So this is problem number 8.1. This is a part of in-text question. Here you have to count the number of sigma and pi bonds in these two given compounds. Now, how you will do it? Again, I will be telling you the result because you already know that how do we count the sigma and pi bond. There is a trick for it if you don't remember. So every 2 carbon or every 2 atom will make a single sigma bond. That is for sure. If there is a double bond, then also there will be 1 sigma bond and 1 pi bond in that. In case of triple bond, there will be 1 sigma and 2 pi bond. Now, I hope the question is much more easier for you. Just try to solve it. Your time starts now. Okay, your time is up. Let us first look at the compound number A. If you look at the compound number A, then here is a representation of the sigma and pi bonds that are present in it. So, there are 4 CC sigma bond. How? So, starting from the left side, if you see the triple bond, then this triple bond is having 2 pi bonds and 1 sigma bond. So, one from there. Then the next adjacent carbon has a 1 sigma bond. Then if you come on to the double bond, then again there will be 1 sigma and 1 pi. And last one at the terminal side, rightmost terminal side, there is a sigma bond which is coming from the CC single bond, right? So total number of sigma bond which are CC are 4. What about the CH? So it's very easy. Total number of the hydrogen will be equals to the total number of sigma bonds due to CH because hydrogen always makes a sigma bond. We know it very well. Hydrogen is monovalent compound and it can make maximum of 1 bond. So therefore the number of hydrogens will be equals to the number of sigma CH bond which is 6 in the given chemical formula. What about pi bond? So if you consider pi bond, then it will be only available in those places where we have multiple bonding. So we have a triple bond and a double bond. So triple bond will contribute to 2 pi bonds and 1 sigma bond. So therefore 2 pi bonds from there. And the double bond will contribute 1 sigma and 1 pi. So that will contribute total of 3 pi bonds in the given compound, which is between carbon and carbon. Now out of these 3 pi bonds, 1 is coming from the double bonded carbon and 2 are coming from the triple bonded carbon. So this is your calculation of sigma and pi. Now, if you want, you can just add those and you can simply get your answer. Similarly, if you look at the compound number B, here we have 3 sigma bond. How? So, between C and C, if you see, then we have 3 carbon-carbon connectivity. 2 are from the double and 1 is from the single. So, the double bond will give you 1 sigma bond each and the 1 single bond will give you 1 sigma bond. That will sum to a total of 3 sigma bond between C and C. What about the CH? How many CH sigma bonds are there? Again, count the number of hydrogens. So 3 to 5 plus 1, 6 hydrogens are there. So 3 sigma bonds are coming from the CH. Moving on to the pi bond, we have only 2 double bonds, and each double bond will contribute 1 pi bond. Therefore, total of 2 pi bonds are present here. Got it? Moving on to the next question. What is the type of hybridization of each carbon in the following compound? So 4 compounds, okay, so 5 compounds are given here. You have to determine simply that what is the hybridization. I hope this is simple to you. So your time to solve this question starts now. Just try to assign hybridization for each carbon that you have in a compound. You don't have a specialized carbon to be marked. Okay, your time is up. So we will see to each and every compound one by one. Before that, we will again remember this tricky part of calculating the hybridization, which is counting the number of sigma bond. How do we do it? So if your sigma bond is 4, the hybridization will be sp3. If it is 3, the hybridization will be sp2. And lastly, if it is 2, the hybridization will be sp. So moving on with this generalization, we can say that in the compound number A, which is CH3Cl, what is the number of sigma bond? It is 4, right? So 3 are from the hydrogens and 1 is between carbon and chlorine. Therefore, the hybridization will be sp3. We can represent the same in the structure here. So here I am slowly representing you introducing you to the structure as well. So this is basically a tetrahedral carbon where the 3 hydrogens are present in the bottom and 1 is present at the top side. Now this position may change. This is a relative position, not an absolute one in this case. And in this case, you can clearly see that the marked carbon is sp3 hybridized. Got it? Moving on to the next one. The next one is CH3 whole twice CO. Here in the CH3 whole twice CO, there are 4 sigma bonds. So that will contribute to sp3 hybridization. How can we say it? Before moving on to that, the structure, we will look at the second carbon. So 2 carbons are present here. One of the carbon is attached to 3 hydrogens and 1 carbon, whereas the other carbon is directly attached to the oxygen and to 3 methyl groups. Therefore, there will be sp3 hybridization and a sp2 hybridization. How can we represent it in the diagram? Here is a diagram. You can see that the carbon which is attached to oxygen, it has 3 sigma bonds and 1 pi bond. So therefore, the hybridization will be sp2. Whereas the 2 methyl groups on the either side are having 4 sigma bond, one coming from the carbon-carbon and the other 3 are coming between the hydrogen and carbon. Therefore, the hybridization for both of this will be sp3. I hope this is clear to you. Moving on to the next compound, which is CH3CN. In this, if you notice, then we have 2 cases. First, the CH3 carbon is having 4 sigma bonds, one between again carbon and 3 between carbon and hydrogen. So the result will be a sp3 hybridization. What about the CN? So C and N are having triple bond. That will give you 1 sigma bond from there, and the carbon-carbon will again give you 1 sigma bond. That will total up to 2 sigma bonds. Therefore, the hybridization will be sp. Can we represent in this diagram? Yes. C, the carbon which is attached to hydrogen is having a triple bond. Therefore, it is having a sp hybridization, whereas the left carbon is having what? 3 hydrogens and 1 carbon attached to it. So it is a sp3 hybridized carbon. I hope this is clear to you. Moving on to the next compound. The next one is HCONH2. Here, if you look at the carbon which is attached to oxygen, which is HCO, so this one is having 3 sigma bonds. One is between carbon and oxygen, one is between carbon and hydrogen, and the last one is between carbon and nitrogen. So the hybridization will be sp2. Can we see it in the diagram? Yes. The carbon is having 3 sigma bonds, whereas the fourth bond is pi bond, which is between carbon and oxygen. Now moving on to the last compound, which is compound number E. Here the compound number E, if you locate, then it has 4 sigma bond for the CH3 carbon. Therefore, the hybridization will be sp3. And what about the other 3 carbons? So there is 3 sigma bond presence in the second carbon from the left. So that will give you sp2 hybridization. Moving on to the next carbon, which is again doubly bonded carbon on the right hand side. So this carbon will have sp hybridization because it has 2 sigma bonds. Okay. So here we are talking about the CN carbon and not the CH carbon, sorry, because the CH carbon is similar to the other CH carbon that we have. So both will have a sp2 hybridization. So we can say that this diagram here, see here, one carbon is sp3 hybridized, the left one, whereas the middle 2 carbons are sp2 hybridized, and the terminal most on the right side is having the sp hybridization, where one sigma bond is coming from the C triple bond N and the other is coming from the C single bond C for the rightmost terminal carbon. I hope this is clear to you. Moving on to the next question, you have to write the state of hybridization again, and in addition to that, you have to mention the shape as well. So we have 3 options here: CH2, 3 compounds here: CH2CO, CH3F, and CHCN. CHN. So this one would be the last question. Your time to solve this question starts now. So this is the last in-text question, right? 8.1, 8.2, and this one's the 8.3. Remember, if you got a sp3 hybridization, your shape will be tetrahedral, sp2 means trigonal, and sp means linear. You have 25 more seconds to go. Okay, your time is up. Now, if you look at each of the compound, then they have 3 different hybridization. How? Let's see. So, first of all, how you will decide the number of sigma bond, hybridization, and shape? So that is all known to you. If it is having 4 sigma bond, it is sp3 hybridized and it will have a tetrahedral shape. Then if the number of sigma bond is 3, the hybridization will be sp2 and the shape will be triangular planar. Whereas if the case is of 2 sigma bond, then in this case the hybridization will be sp and the shape will be linear. If this table is true, then we can finally calculate the hybridization as well as the shape for each of the given compound. Starting with the first compound, which is CH2O. In this compound, if you notice, the number of sigma bond is how much? It is 2. Therefore, the hybridization will be sp. How we are saying it is that the number of so if you see the first compound here, the number of sigma bonds will be 3. How? So there is 2 sigma bond with the hydrogen for the carbon and 1 sigma bond with the oxygen. Therefore, it will have a sp2 hybridization. If it is sp2 hybridized, that means the shape will be trigonal planar. So we can represent it here, sp2 or trigonal planar carbon. This is the first one. Moving on to the next compound, which is CH3F. In this compound, the carbon is having how much sigma bond? 4 sigma bond. 3 from the hydrogen and 1 from the fluorine. So all of these 4 heteroatoms apart from carbon are what? They are monovalent atoms, right? So they will make 1 sigma bond. that will result in a sp3 hybridization. Now, if you consider that will be tetrahedral due to this sp3 hybridization, we can represent it here same in this given figure. Moving on to the last one, which is which is question number C. So here the compound is HCN and there are 2 sigma bonds present. One is between carbon and nitrogen and one is between carbon and hydrogen. Therefore, the shape will be linear and this can be represented here in the diagram, a linear shape. Moving on to the next question, which is a practice problem. Here, you have to look at the hybridization of the each carbon. So, you are marked with carbon number A, B and C. So, let's see what is the hybridization. You have 1 minute to solve it. Your time starts now. You have 30 more seconds to go. Okay, your time is up. So, we know already how to decide the hybridization. You have to count the number of sigma bond, and if the sigma bond is 4, the sp3 hybridization is counted. Then 3 sigma bonds, sp2 hybridization, and 2 sigma bond, that means sp hybridization. Again, with this generalization, if you move on to each carbon, then starting from the carbon number A, we can say that the carbon number A is having 4 sigma bonds. How? So 3 are coming from the carbon and hydrogen and 1 from the CC sigma bond. Therefore, the hybridization will be sp3 for the carbon number A. Then our next carbon is carbon number B. In this carbon number B, what we have? We have this 3 sigma bond. Why 3 sigma bond? Because 1 is attached to the oxygen, right? Then we have a carbon hydrogen single bond. Then we have a carbon carbon double bond. This carbon carbon double bond will give you 1 sigma bond. Carbon hydrogen will give you 1 sigma bond and the carbon oxygen will give you 1 sigma bond. If there are 3 sigma bonds, that means the hybridization will be sp2. Moving on to the last carbon type, which is carbon number C. The carbon number C is having, if you notice which is the carbon number C, just look here, right? So this carbon exactly here, which is a part of the benzene ring, it is having 2 carbon carbon bonds, right? So there is a double bond with the carbon on the right hand side from the upper part, and the lower part is having carbon carbon single bond. So both will contribute to 1 sigma bond each, and the carbon oxygen will also give you a sigma bond. So that will give you a hybridization of sp2. So this was all for today's class. Thank you for joining the session. I hope you enjoyed it.